about this tonight's speaker, we have annually a scholarship that the Channel Islands chapter independently fundraises for and provides for students who are studying native plants in the Ventura County and Santa Barbara counties. And this was spearheaded by Connie Rutherford in 2019. And in 2022, a scholarship committee was formed to take the baton on from Connie when she left town. And since 2022, the scholarship committee has worked to provide opportunities for students through the scholarship. So we raised the scholarship from $500 to $1,500. And I believe a former scholarship recipient is in the audience, Joanna Tang. Just a shout out, former scholarship recipient. But I just wanted to say thank you to all of the humans that donated to this scholarship to make this opportunity possible. And tonight I'm really excited because we're hearing from the scholarship recipient of 2024. Yes, 2024. And that is Selene Lopez, who is a first generation Latina college student from Oxnard, California, and just received her BS degree in biology and environmental science and resource management from CSU Channel Islands. She comes from a tight-knit family and grew up spending a lot of time with her grandmother. Her grandmother would often point out medicinal herbs going around town and sometimes take a small handful to them to use at home. Her grandmother passed those remedies down to Selene, and in this project, Selene studied California native plants in a controlled scientific setting and also spreads awareness about the importance of these plants to the Chumash of this region. So I'm going to hand the microphone over to tonight's speaker, the 2024 scholarship recipient, Selene Lopez.
Hi, everybody. So my name is Selene Lopez, and I would like to express my gratitude to the CMPS Channel Islands chapter for awarding me the scholarship. Which, with their support, I was able to work on this project in the Becerra lab at CSU Channel Islands called the Antibacterial Potential of Chumash Medicinal Plants of California. And I also want to give a big shout out to my lab. Hold on, my clicker isn't working. Oh no. Here to my lab, because this project wouldn't have come this far without the collective effort of everybody involved. And this research is really a product of collaboration and teamwork. Before we get started too, I want to do a little land acknowledgement. We would like to acknowledge the land upon which this research is being conducted as the unceded territories of the Chumash people, and we pay our respects to the Chumash elders, past, present, and future, for they hold the memories of and traditions and culture of this land that we work to protect. There's this mountain on our campus that we call Round Mountain, and while a lot of people know the name Satwila as Rancho Sierra Vista Satwila in Newberry Park, this is actually the true site of Satwila at the top of this mountain on our very campus. And I just think that's really important to tell everybody. And we also hold restoration events once a year to restore the trail up to Satwila so the Chumash community can begin using it again. Um, so I'm sure that many of us know that our Chumash were our early land stewards. Um, well, first, I'm not Chumash, so everything that I know of them is just from what I've read. But they were our early land stewards, and oh gosh, um, they have been the original land stewards of this region for thousands of years. So they've been able to track things like the seasons, solstices. They even were aware of like water and soil quality. And to them, everything on this planet is alive and connected. So even water, plants, rocks, trees, everything is connected in this spiritual and ecological system. And these plants and animals and things that give us sustenance, they aren't just for us to use. They offer us gifts to sustain us and to heal us. And because of this, because the earth takes care of us, humans have a responsibility to protect the earth so it can continue to give to our future generations. So the Chumash very much believe in the mind-body connection. So when someone is sick, it's seen as an imbalance or a disharmony between the body and the spirit. So they've developed their healing practices to treat symptoms, but they also place a really big importance on bringing back spiritual balance. And not all, but a lot of the same plants they use in spiritual ceremonies also have medicinal properties that help with common illnesses, such as like white sage, coastal sage, mugwort, yerba mansa. They were all used in smudging rituals, but they were also used as remedies for colds and infections and other ailments. So today we categorize traditional medicinal systems um, under complementary and alternative medicine, and pretty much all cultures around the world developed their own system of medicine. And while they didn't have a scientific framework the way we do, or the way we know it, they figured out what works through trial and error and observation. And people have been doing this for since the dawn of man, basically. So we humans have kind of evolved alongside plants because we have relied on them as a medicine and food and other things. So we consume these plants and we react to them, and sometimes that's a really good reaction, and sometimes it's not a really good reaction. But over time, we've developed adaptations, so our physiology recognizes and processes certain plants. And this actually varies by region and culture because, you know, everywhere has their own different plants, and I think that's really interesting. Um, and actually, a lot of our pharmaceuticals today are based on natural compounds too. For example, we've derived antibiotics from bacteria and fungi like penicillin, but we don't just extract them straight from nature. We use them as like inspiration and we synthesize them in labs from like other chemicals. And we do this because it allows us to mass produce them, but we can also make them stronger so they work more effectively. However, by making them so strong, we kind of put a huge selective pressure on bacteria. And while they treat infections very well, antibiotics can leave behind resistant bacteria. And this raises this question of do could plants that have been historically used for medicine contain antimicrobial compounds that might help us address antibiotic resistance? So what is antibiotic resistance? Um, Antibiotic resistance or antimicrobial resistance happens when populations of bacteria evolve in ways that make antibiotics less effective at killing them or stopping their growth. This actually happens naturally because bacteria have always been exposed to antibiotics in the natural environment. Um, but it's happening faster because of our strong antibiotics. And we also do things every day that contribute to antibiotic resistance, such as overuse or misuse of antibiotics. Um, we use antibiotics in our agriculture and our livestock. Um, Healthcare is actually a really big spreader of antibiotic resistance, and so is travel. Um, so that got people thinking that instead of relying solely on making stronger antibiotics, maybe we can look at other ways to fight infections that maybe don't put as much pressure on bacteria to develop resistance. And one area that is of a lot of interest to researchers today are plants because they produce a mixture of phytochemicals, and these phytochemicals all have different functions. So they can basically attack bacteria in different ways at once. Um, and this actually makes it kind of hard for bacteria to pick up resistance genes because they don't really know what gene will give them resistance. There's also potential for synergy with antibiotics. So naturopathic doctors sometimes prescribe a plant with an antibiotic to kind of help the efficacy. And also sometimes plant combinations help them or help each other work better, like in this picture right here. Curcumin, tomato extract, and vitamin C work together, work way better together than individually. Um, And actually, curcumin, tomato, and things like garlic and peppers all have antibacterial properties too. So you can say like salsa has antibacterial properties. So we needed kind of like a starting point for this project. Um, we really just knew that there are a lot of native plants around us. And because we're in California, we were pretty sure the Chumash might have used them. Um, so we needed a starting place. And while we were looking, we were trying to get our footing. We went through the library and we found this book called Healing with Medicinal Plants of the West. And it was written by Cecilia Garcia, who's a Chumash healer, and she documented like over 100 plants in this book. And she partnered with Jim Adams, who's a doctor of pharmacology at USC. And he did research on these plants and they published this book together. And we used a couple other sources too. If you want, you can scan that QR code in the corner and that'll have our plants and the sources.
Selene, I think I'm back. Yeah, there. Now we're on the slide with the with the book. That's what I see anyway.
Oh, really?
Yeah,
My,
now you're on the.
that's so
That's weird,
interesting.
huh?
Yeah, because my
I
screen right now is showing the book. Is that what you guys see?
I don't know what everybody else is seeing. I'm seeing your uh, kind of
Hmm.
messed up. Do
I'm
you
seeing
want
a
to?
list of plants. Looks like it went
It's a
past.
That's
lot of
Yeah,
different
that's so
plants.
interesting.
Okay, go back
try
Try,
one
sharing and
slide.
then
yeah. Well, I mean, what I'm seeing right
yeah.
now
Now,
is not the plant, it's the book.
And now I'm seeing the,
Now I'm seeing all of the plants, but you guys are probably seeing the next slide.
no, we're
nope,
seeing the
we're
plants.
now on the same page.
Oh,
Now we're on
okay.
the same page. So it's all good.
Okay, cool. Um, so we narrowed it down from like 100 something plants to these 18 based on what the literature said they were used to treat. And a lot of these plants do have multiple uses, but I we also have to say that the Chumash people continue to use these plants for medicine and spiritual purposes. And a lot of these plants also have ceremonial and cultural significance. So these are just some of the plants that they use for respiratory illness. I know we're probably familiar with the sages. So white sage is important in cleansing and smudging ceremonies, but it also treats cold and coughs and things like that. Purple and black sage are similarly used for respiratory illnesses, but they're also used in ceremonies for focus and clarity. California wild buckwheat is used for respiratory infections, but it's also an important plant food. Lemonade berry helps with sore throats and respiratory conditions. The Chumash used to suck on the berries because they're like kind of tart and sour. Coastal sagebrush treats colds and congestion and respiratory infections, but it's also used in purification rituals. Um, these are some plants that they use for skin and wound care. So yarrow, California fuchsia, and manzanita can be used as poultices or paste for cuts and wounds and rashes and burns. Um, yerba can be used as like a wash or a bath for sores. Um, and it's also really good for warding off negative energy. And chaparral bush mallow, it's really soothing. And it's also said to bring people comfort and relief, kind of like California wild rose. And these were applied to cuts and rashes to help with healing too. These guys help with digestive problems. So yerba buena is generally a soothing plant. So it's good for things like stomach ache and nausea. Toyon as well is good for stomach aches. And arroyo willow, Brita bush, and wild buckwheat are really good for settling the stomach and aiding in digestion. And arroyo lupin is a mild detoxicant, and so it's used for digestive balance. Um, and lupin is also used for urinary support because it's a detoxicant. And mugwort supports kidney and bladder health, but it's also known as dream sage because it helps bring people pleasant dreams. Um, Manzanita, California wild buckwheat, yerba buena, and yerba mansa are all super good for urinary system support. And by this time, you're seeing that I'm kind of repeating plants, and that's because they have a ton of uses. So let's move on to the bacteria. So first, because of most of us working, I think all of us working on this project are undergraduates at the time, we're not really used to allowed to use bacteria that could actually make us sick. So there are a lot of rules around that, and only like medical clinical researchers and government agencies can work with the actual pathogenic strains. But we use non-pathogenic bacterial analogs, which are like the same thing, just with like a missing piece that makes them non-pathogenic to us. And that's why they're used as like a model for things like what we're doing right now. And so first we started with these three: Bacillus subtilis, Pseudomonas fluorescens, and Escherichia coli. These guys are naturally occurring and they're not pathogenic to most healthy individuals. But these guys gave us a good foundation for later when we started adding the more clinically significant bacteria. So these guys are major culprits in hospital-acquired infections like Staph aureus, which loves infecting wounds. Enterococcus faecalis and Pseudomonas aeruginosa cause infections in like surgical sites. Shigella flexneri and Salmonella typhimurium, give you really bad dysentery and intestinal issues. Um, and yeah, bacteria are really easy to grow. You can just find any tube laying around and just kind of wipe some and then grow it. But that's not really the case for plants. So we didn't feel comfortable going out harvesting in the wild, really, because we weren't sure who really dictates any rules around that. We also tried to buy a couple plants to use, but we didn't like doing that because they were really small. But we reached out to the CSUCI President's Chumash Advisory Council, and they just kind of make sure that their culture and heritage is respected by campus activities. And we asked one of their representatives to come out and train us in how to harvest plants in a culturally considerate manner. So first we had to form a relationship with the plant. Like I said before, you can't just come up and take it. It's alive and it has to be treated respectfully. So we would first get acquainted with this plant. So for example, I would say, hello plant, my name is Selene, and I really need your help studying your antibacterial properties. Would you let me do that? Would you let me have some of your leaves for my study? And you can interact with the plant. I like to touch leaves and smell it. And sometimes I'd say like, oh, the bees love you today. And before we take from the plant, there must be like this exchange. So, whenever we take something from a plant, we have to leave something with it too. So it could have been prayer or song, but we used water or hair. And then we would never take from anything too small. Leave, we would leave like white sage if it was flowering alone, and we wouldn't touch anything that was federally protected. And later, after the study, we'd come back and revisit the plant and give thanks and maybe water it again. And that's just to keep the relationship going.
Selena, may I
Yes.
just ask you, the slides haven't been loading very well, and so what we're looking at right now, you've got the top says cultural considerations, ethical harvest, which is what you're talking about, but all of the imagery is bacteria.
That is so
Which
weird. There.
I know it's just there's a lag somehow in the way the slides
Oh,
are loading. Could you just go forward a couple of slides and then go back again and read there? Okay, and then just go back. There. Now we're on the cultural considerations, ethical harvest, and we can see the
okay.
entire slide. I'm so sorry. I don't know what's happening, but I just thought we could maybe reset for a moment.
Yeah, I don't know what's going on either.
It's just
Um,
somehow the way the internet is loading the slides. It's okay. All right. So
yeah,
I think we're
okay.
now seeing the slide you were just talking about. And so we can go forward. Thank you.
Okay. Okay, so we harvested using culturally considerate methods. Okay, can you see the next slide now?
No.
Not yet. No, not yet. There we
I
go.
want to suggest, yeah, if you go forward a couple of slides and then go back to the one that you want, that kind of refreshes the cache. There's a problem with the image caching. So I think with each
Okay.
time, if you go forward a couple slides and then go back to the one you want, we should see it.
Okay, thank
Yes.
you.
So now we're seeing plant preparations. It looks perfect.
Okay, awesome. 1 second. So after we harvested, we had to wash the plant to get any like dirt or like bird poop or there are other like microbes that actually live on the plants. We had to get that off. And then we dried it in an oven for like 3 to 5 days, just to make sure it's totally dry before we ground it up. And then we began extracting. So we couldn't use the plants in the same way that they were used traditionally because it wasn't controlled or like consistent for scientific research. And these are like the poultices and things like that that would be hard to test. So we decided to use just macerations to stay consistent, and macerations are just ground up plants in a solvent, and the phytochemicals or the good stuff, they should end up evenly distributed in the solvent. So our first question was, what solvents should we use? Should we use water because it's like a tea, or like a modern organic solvent like alcohol, so it's like a tincture? Um, we wanted to try different ones with varying polarities because the different polarities draw out different phytochemicals. Like dissolved like, and we don't know what's in these plants at this point, so this was like our most logical first step. So we tested regular water, ethanol, acetone, and hexane first, with 1 gram of plant to 10 milliliters of solvent, just soaked overnight at room temperature. And then after that, we figured out what worked better. Um, so we just moved on. We upped the concentration a little bit. We used less solvent. And then we put this in a shaker so there's like constant agitation. So we had to do antimicrobial susceptibility testing. Oh, can you see that? The slide with the big circle? Yeah. So we had to do antimicrobial susceptibility testing of these bacteria, to the plants that we used. And there's a lot of different ways to do that, but we used the Kirby-Bauer diffusion method. And this method just classifies bacteria as resistant, intermediately susceptible, or susceptible to an antimicrobial agent based on the size of the zone of inhibition. And that's that little clearing around each little disc in this big circle. You see that? These are a little light. Um, and then we also use the Clinical Lab Science Institute of Performance Standards for Antimicrobial Susceptibility Manual to help us make sense of the data. Not really for comparison though. Here, bacteria categorized based on how they respond to antibiotics. They can be resistant, intermediate, or susceptible. And that's also divided by the bacterial group, gram-negative or gram-positive, which is based on structural differences. Gram-positive has 1 cell wall, gram-negative has 2 cell walls. So you can kind of like make sense that the gram-negative ones with 2 cell walls are less susceptible to treatment. So this is our results for the very first test of the solvents. These are mean zone of inhibition sizes.
Selena, can you
So
go
forward?
a couple slides?
Yeah.
Thank you.
Yeah, now go back.
Here you go. Oh. Is this good?
Solvent impacts antibacterial activity.
Yeah. Okay. So you can see there are a lot of zeros. Those are the white boxes. And that's expected because a 1 to 10 ratio is not very potent. But we weren't really looking at the size of the zone of inhibition. We were just seeing which solvent gave us the most results. And that happened to be ethanol. And acetone worked pretty okay too. And water did well for some of them. and so did hexane, but ethanol was the best, so we moved on mostly with ethanol. So this is our first run of testing stronger extracts. And as you can see, we got some better results, some larger zones of inhibition, but the bacteria was still classified as resistant. That's all those green boxes here. But we do have some results that do stand out, like P. fluorescens was actually quite susceptible to California fuchsia. And this is kind of wild because it wasn't very strong right now. I'm so sorry, was that someone trying to say something?
I'm not sure you're on the, we're seeing the right slide. We're on, yep, there you go. Now we are.
Okay. So, yeah, okay. So here is, this column represents P. fluorescens, and California fuchsia is down here. And you can see that at this concentration, it was already susceptible, but it was also intermediately susceptible to manzanita. And these guys do treat like respiratory issues. But there were also some that got really close, like white sage and black sage and mugwort. E. coli was resistant to most things, and that's kind of expected. E. coli is a very resistant bacterial strain, and B. subtilis, it was pretty similar to E. coli as well. Can you guys see the next slide? Okay. So this is our results from testing more bacteria. And you can see that gram-negative bacteria, that column on those 3 columns on the right, the gram-negative bacteria are more resistant. But we got some cool results from Shigella flexneria, which is intermediately susceptible to California fuchsia, white sage, and lemonade berry. And S. aureus, Staph aureus, is actually susceptible to white sage, black sage, and intermediately to coastal sagebrush. And S. aureus is that skin infection bacteria. Okay, this is the next slide. Yeah. So we tried to also combine the plants and see if they work better together. And unfortunately, we didn't see that the zone of inhibition size increased. And it kind of looked like the extracts worked worse together. But I actually think that something went wrong here with the storage. We actually tested this 3 weeks later after the initial testing, so I think they might have degraded a bit by then. Then we wanted to see if the bacteria is actually being killed or if the growth is being slowed down. And as you can see by the teal boxes, or by the purple boxes, most of them were just slowing down bacterial growth. So we did have a couple that impressively were already killing bacteria like black sage, coastal sagebrush, and white sage, but only for some bacteria. And so this kind of just shows that this is bacteria dependent and plant dependent. And from our initial testing, we also saw that it's concentration dependent, which makes a lot of sense because more solvent can draw out more of the phytochemicals, and so it might work better. But it's also solvent dependent, as you can see right here with coastal sage and ethanol. It kills bacteria, but if
this slide did not advance.
No.
Had a couple go. Yeah, back
This
there.
one?
One more.
Yeah.
We saw that one. Now next slide.
Okay. Well. Okay, so we're here. There's two. Okay. So coastal sage and ethanol was bactericidal. It killed bacteria, but in acetone, we saw that it only slowed down the growth. And that's the same case for white sage. And interestingly, California fuchsia was only bactericidal, killing bacteria in acetone and not in ethanol. And then we were wondering, like, what is the smallest amount of this plant extract that we would need to have this antimicrobial or antibacterial effect? And you do this by testing different concentrations of the extract against the bacteria. And so for white sage, the minimum inhibitory concentration of S. aureus is 0.69 milligrams per milliliter, so that's super duper duper tiny. And you can see that for the gram-negative bacteria, E. coli and P. aeruginosa, it's about 4 times more, and that is probably because of that second cell membrane that they have that makes them a little bit more resistant. And then we also were interested in seeing what is in the plants actually doing the work. So we went through phytochemical screening, and that just detects, it gives us an idea of what is in there. So flavonoids, phenols, tannins, triterpenoids, and a bunch of other broad classes of compounds. And then after the results for that, we found that all of our plants have phenols in them, and only a few of them have flavonoids. And we only found tannins in white sage and triterpenoids in toyon. And then we were able to move on to GCMS, which separates the chemical and identifies it based on mass and how easily they evaporate. And that's this picture down here on the right. And it's not really fun to look at. And that's fine because the GCMS machine just kind of matches it to us, for us anyway. So we found that eucalyptol is the main constituent in white sage. And unfortunately, this was the only chemical we were able to identify, but we know that white sage also contains things like pinene and thujone and camphor, which is found in the camphor tree, and saponine, which is found in the Peruvian pepper tree. And so these plants, they're all invasive or non-native to California. And that's kind of expected because a lot of phytochemicals across hundreds and hundreds of plants are quite similar. So the key takeaways from my data are that at this concentration, some plant extracts do show antibacterial activity against clinically relevant bacteria, which is awesome. But that means that we confirm the uses that the Chumash have been using for thousands of years, for millennia. However, their effects aren't as potent as modern antibiotics, and that makes sense because we literally design antibiotics to be extremely strong. Even with the small amount of plant that we use, things like white sage, black sage, California fuchsia, and wild buckwheat still showed considerable activity actually, and some bacteria like Shigella flexneri were already quite susceptible to some of the plants at this concentration. But the activity varies widely. Some bacteria are just intrinsically more resistant than others, like we saw with the gram-negative bacteria. But the activity also depends on the plant itself, and as well as the solvent and the concentration. And however, for extracts to be considered for development as modern antibiotics, a lot more research is needed, like things determining like safe and effective dosages for human use and understanding their mechanisms of action and just running more advanced clinical trials. And that's way beyond what we're able to do. But whether or not research proves their effectiveness, people are already using these extracts, these plants, I mean. And that means that we need to think about how they're sourced and how accessible they are and what happens if demand increases, especially because research like this kind of helps expose their uses. So from a conservation standpoint, maybe we don't want to encourage more people to use these native plants, because we don't want anything to become too popular. And many of us have heard of things like white sage poaching, and we don't want like any other plant to experience that. So if native plants suddenly gain popularity, they would face this same risk of poaching. So let's shift our perspective. Like, what else can we do? So I think we can focus on education and advocacy. If someone is interested in using these plants medicinally, we can make sure that they understand the history and the cultural importance and ecological role of the plants. Because maybe if they're aware and if they recognize the plants as like important and meaningful, they might make the choice to respect it and leave it alone in the wild and maybe not use it. We can also encourage people to grow the plants and only use what they grow, or to buy the plants from ethically cultivated sources. Um, and that's just going to relieve the pressure on the wild populations. But we can also tell them about the alternatives like eucalyptus instead of white sage. And that'll add possibility to also manage invasive plants while we educate people about these native plants. And there are a lot of different directions that we can take this project. We would like to test more plants, but we're just kind of unsure of how to get access to more plants. We can also test more bacteria and extend it into things like fungi, which someone is already working on. And we can also optimize our methods. Like, for example, tea works better for certain plants. So we have some people working on specifically teas. And we can also expand the scope of the study. We have a couple of people looking at the cytotoxicity and antioxidant properties in a planarian model of these extracts. And that is kind of getting into the territory of would this be safe for human consumption? Thank you guys. Questions or comments?
Thank you, Selene. And apologies about the photo slides loading. That was a hassle. There are a couple of, while people in the audience, live audience, are thinking through questions, one thing I want to say is thanks for sharing your research. And also, there were 2 questions in the comments. One of the questions was about the effectiveness of when different plants are combined, and if you were able to look at that when you compared the salsa analogy.
What was the last part of that you said? I'm sorry.
I think someone put a question about combining native plants and their effectiveness once combined.
Oh, I think I missed something at the end of that before, but yeah, we did combine them. There's a slide back here. This is basically what all of the data looks like. I could have shown you a chart like this. I'm sorry, can you see the pictures?
Yes.
Yeah, I could have shown you a chart like this, but I think this showed what our data looked like better, like how the zones of inhibition were smaller. But this is probably because we didn't store the extract correctly or something like that. And we also waited a little bit too long to do this. So it didn't work out as we expected it.
Another question from the chat is if you just used leaves or if you used other parts of plants.
For most of the plants, we did use the leaves, but there were a couple that we used the flower, like the petals for. Specifically, I think California rose and chaparral bushmallow. But pretty much everything else was the leaves.
Thank you. Terry, you have your hand up?
I do. So I have 2 questions. One is really more of a kind of a question comment about the synergy experiment, because I think that's really pretty interesting and may give you, I know those experiments that you didn't work, but I wondered if you controlled for how much you put into the experimental system, because you would actually be diluting them 1-to-1 if you were just adding both of them into, you know what I mean? Like there's a dilution factor there.
Yeah, I guess we didn't think about that, the dilution factor too much there. What we did is we took the original extract and we just kind of did a 50-50 volume and we just mixed them.
Okay.
So yeah, maybe we did see a dilution thing happening.
Because that's kind of what the data looks like, that you got kind of half the effect.
Yeah, I mean, it's
Anyway,
something
my
that
other
we can look into.
question, yeah, my other question, which I told you I was going to ask, is this is really exciting. Getting your hands wet, doing this kind of research in the lab. And I know you just graduated, so what's your next step? What are you going to do next?
I did apply to grad school, and I know that that's actually been hard for a lot of people this cycle. But I'm still waiting on a couple, and I'm holding on to some hope. But I know that that might not work out. So I have also been interviewing for like internships. And I just interviewed for one with the U.S. Geological Survey a couple weeks ago, and I hope to hear back from them soon.
So I'd just like to add a comment to that a lot of students are getting rejections because their graduate programs are dependent on federal funding, which is not coming through. And so this is something we should all be aware of and, fight the good fight and try and get our students funded again.
Thanks,
Yeah,
Terry.
fight the
And
good fight. Amen.
yeah. Anton, do you have
Yeah, I was wondering with your experiment, I don't know if you can hear me that well,
I can hear
uh,
you.
but do you think that maybe they are less susceptible? Because I know like recently a lot of bacteria and things have gained resistances because of the strength of the antibacterials we're using. Do you think that may have contributed to not the disappointing results, but how they were less effective than you were expecting?
Are you referring to the synergy compared to the other results?
I think just in general.
Mm, I mean, natural plant compounds, even though they're natural, they do still contribute to antibiotic resistance, just because of what they do. They attack the bacteria. Um, but I don't think that, I'm not sure if I'm going to be answering your question correctly. I don't think that between our trials, there would have been resistance, like evolving already, mostly because for every trial, we use like the same like stock solution, and we don't really continue using that after it grows. Does that make sense?
Yeah, that makes sense. Thank you for answering.
Yeah, you're welcome. Any other questions?
There's another question in the chat, which was about how there were a couple of plants that you weren't able to harvest in 2023, and some of the people were wondering why that was.
Okay, so there are a few plants that we collected on campus, and they were just kind of in some weird random little patches, and they look like weeds. And unfortunately, our campus facilities kind of indiscriminately wax everything down. So a lot of the plants just didn't grow back. Like yerba monster, for example. I've been watching it, and it's nothing. Yeah.
There's another
I'm
question.
sorry.
Oh,
Go ahead.
are you sure? Go ahead, Terry.
Yep. No,
Cool.
go ahead.
There's another question about native medicinal plants that could help with infections from eggs, and that include eggs of native birds that could have been used as food. Do you have thoughts on that?
That is interesting. I know there are plants that were actually mentioned in our book that were used to treat various STDs. None of them mentioned specifically AIDS, though. But that doesn't mean that it's not possible. It might just not be documented yet.
Sorry, I meant
But it
eggs,
could be cool. Oh, I'm
like
so sorry. What?
bird eggs.
Oh, yeah, eggs? I'm
Eggs, yeah.
not sure that I like understand the question then. Can you repeat it one more time?
Yeah, I'll quote it directly. I like that these native medicinal plants could help with infections from eggs that have included eggs of native birds that could be used as food by Chumash. Your thoughts? Question mark.
Huh. I'm so sorry. I think I'm still not understanding the question. Hold on. Let me look in the
I
chat.
could, I could ask. This is Roy.
Yeah, yeah, please.
Am I coming across so clear? My computer sometimes acts up, but um, what I was wondering is like salmonella poisoning that could be in, quail or native pigeons or other native bird life
Uh-huh.
that might have been sought as food, that they might have had a knowledge to treat that kind of an infection if they
Um,
ate the eggs and they were that might some of these native plants. I just think it's excellent what you're doing, and that it's on a start of the path to maybe answering some questions about when
uh,
native peoples get sick.
thank you, first of all, thank you. And they probably did have some idea that they could get sick, like the salmonella on the eggs could make them sick. Um, but honestly, I don't have much much of an answer for you after that. But thank you anyway for your support.
Selena, we have another question, and then Kent, I see you have your hand up. But the question in the chat says, can you talk a bit about your experience learning info from books and/or Chumash elders?
Um, we didn't really learn anything directly from a Chumash elder, I think, or unless you mean the Chumash elder that wrote our book. But I thought it was kind of a beautiful experience because the book was kind of weaving how we can use our modern medicine and our historical traditional medicine to help us live healthier lives. And I just thought that was, I think it really heavily influenced how I framed this presentation, actually. Um, but it was a really awesome experience, especially like also like learning how to harvest plants with using culturally considerate methods. I really identified with that too. And I just really love this project.
Thanks, Selena. Kent, do you want to ask your question?
Right. Sorry I arrived late. My question is any of this being processed commercially? And if so, is that a good thing or a bad thing?
Um, None of these have been processed commercially for antibiotics, really. And actually, I also don't think for other purposes, like for cleaners or essential oils. And I think that's a good thing, um, because there are plenty of other good sources of the phytochemicals in other plants, and we don't have to use these. We can use, like, instead of white sage, like I said, eucalyptus, cut down a eucalyptus tree and leave the white sage alone. Um, so I think it's a good thing that they haven't been commercialized.
Thank you.
You're welcome.
Great. Are there any more questions?
Name of the book is
Yeah.
yeah, the book is, yeah, let me go back. It's all the way up here. Here, Healing with Medicinal Plants of the West. There's like 12 editions out. So you can probably find one for like $5.
And there's a QR code to more sources. Great. Rochelle?
Thank you,
Hey, I
everybody.
just wanted to say, because I don't know if you're reading the chat, but different people are saying thank you, great job, and I wrote that as well. That I thought this was really interesting because I've read that book and I garden with native plants, and I drink teas from coastal sagebrush and white sage in particular, and I just think it's really interesting that you chose this area to research, and I'm really glad that you shared with us. It was a really fascinating presentation, and I'd love to see more of this kind of thing from you.
Thank you so much. And this was a group effort, so I would also like to thank my entire lab for contributing.
Oh, awesome.
Yeah. And then thank you everybody that came out too. Thanks for being patient with the slight technical difficulties.
Totally. Andrea, did you have one more question for us? Are you going to be our last one?
Well, I wanted to say to Roy, you know, in those days, they didn't know there was bacteria. And so they were treating symptoms, they weren't treating bacteria. So with eggs with salmonella on it, they didn't know there was salmonella there. They got a stomach ache. And so they were treating
Yeah.
the stomach ache, not the eggs with bacteria.
Yeah. I guess
So
I
So
optical.
think that's
it's a
kind of what I
different
meant.
idea. No. It has nothing to do with what you were saying. It's his idea is just different from what was true at that time.
Yeah, I'd
To
just
that?
like to add that salmonella and eggs is kind of a modern problem of the way we grow eggs commercially. Certainly, there would be the occasional case of salmonella from eggs in a, more natural kind of living population, but it's really the way that we harvest our eggs. So, and all those chicken houses that chickens are not
Evil
treated
chicken
very well. But
houses.
we also, some people know this, but in America, commercial eggs are washed. And nowhere else in the world is that the case because there's quite a bloom of protective compounds and bacteria that are naturally on the egg when it's laid. So it's just very interesting. If you have your own chickens, boy, are you lucky.
Thank you, Carrie.
So there's this old book. It's called Chumash Healing by Walker and Hudson. I don't know if you got to look at
Oh,
that one.
I don't think we looked at that one. We did look at Chumash Ethnobotany by Jan Pembroke, if you heard of that one.
Yeah, well, this is an older one.
Oh,
Let's
Who's
see.
the author
maybe
of
we
that
can look
again,
at it.
Andrea?
It's 1993.
Wow.
And the
Okay, maybe we
authors?
can look at it. Yeah.
I got a copy if you want to borrow it.
Is my voice coming through?
Yeah.
Oh, hi. This is Lanny.
Hey, Lanny.
Hey.
I also wanted to thank you for your great presentation, and I'm so inspired to see that you're doing this and the kind of attitudes that you have for the plants going through it.
I think you kind of were cutting in and out a little bit. Could you repeat that last part? But thank
It's
you for
all
your
what
support.
we all, I think all of us native plant lovers.
Oh, yeah, yeah.
Okay. All right. So let's see. Oh well, I don't know how to fix that right now. Can you hear me now?
Yeah, yeah.
So I just wanted to add something I thought was interesting. Can you still hear me?
Yes.
From the discussion about what the Chumash might have done getting sick from eating eggs. I studied with Juanita Centeno in the 1970s, and one of the things that she told us was that sometimes, like if there was let's say a whale came up on the shore and there was so much food, all the people came and gathered, and some people would just overeat, especially if they were really hungry coming into it. And that when people got sick from, at least from that overeating situation, she didn't go into more detail. She said they drank a tea of coastal sagebrush, which is one of the
Hmm.
herbs that you mentioned that had antibacterial properties. So I
Yeah.
to throw that, into the mix there.
Very cool. Very interesting anecdote. Thank you.
And I mentioned in the chat comments, I'm going to be at Channel Islands campus tomorrow, getting ready for a class that I'm teaching starting next week for the OLLI program on edible medicinal plants of the Channel Islands campus. And bring a mud from the District of California and make sure that it gets into the library in case, because it sounds like maybe they don't have that particular book there. although I have to say I drew a lot on from Garcia and Adams. I studied with Jim Adams for a number of years, and he studied with Cecilia Garcia for 14
Yeah.
years before that. So that is a great book. But
I
you know,
agree.
too many references when you're in this business.
Wow. Thanks for sharing that. That's amazing.
Great. Well, we are at time. Selena, thanks so much for sharing your work with us and for soldiering through that technical difficulties. We're really grateful for how gracefully you're able to respond to that. And on behalf of the board, I'm so thrilled that you were able to receive the scholarship and share with us about the amazing work that you and your lab mates are doing.
Thank you so much.
Yes.
Thank you so much, Annie and board, Terry, Andrea, and everybody else. This was a really fun project, and I had a lot of fun presenting to you guys tonight too.
Thanks so much.
Wonderful. Thank you so much.
Bye, everybody.